I'm Mandy Whaley. I lead our Azure DevTools team, and I'm excited to be here with you at Build. In this session, we're going to share some of the new Azure and GitHub features and tools that can help you take your application from code to running in the cloud, both quickly and securely. In this session, I am joined today by April Edwards, Senior Cloud Advocate and DevOps Practice Lead. We're also joined by several of our team members in chat who can help answer questions along the way. Today, we're going to talk about the need for fast and secure developer workflows and two key capabilities that can help you build this practice: using best-in-class developer tools that help you get from code to cloud in minutes, and how you can embed security into your developer workflow using Azure, GitHub, and VS Code. Along the way, we'll share some demos, and we'll leave you with some information about how to try out these new tools. Digital transformation is reshaping the way that we work. In the past, we believed that every company was going to be a software company, and that has become a reality. Now, every company is a software company. In a recent survey with forward-thinking business leaders, 91% see digital transformation as a way of sparking innovation and finding efficiencies, while another 85% say they must offer digital services or risk becoming irrelevant in today's world. Developer velocity is one of the keys to unlocking these opportunities. Modern development techniques accelerate innovation and revenue. More specifically, those adopting modern engineering practices, including DevOps practices, can see a 4 times greater revenue return than those that don't. This data comes from research we did with McKinsey that scored companies on a developer velocity index. What's more, the automation that DevOps enables also dropped the cost to deliver applications, with companies seeing a 74% decrease in app development cost, and while being able to deliver innovation 55% quicker. Companies that embrace automated, secure DevOps and developer experience practices have an edge against their competitors. But how? Where should you focus to build these capabilities? The fastest and most proven ways to start this journey are through public cloud adoption, open source adoption, and providing best-in-class developer tools for your development teams. Cloud adoption, unsurprisingly, has a high impact for non-technology companies. In our study, companies with a high adoption of public cloud score 30% higher on overall business performance, including innovation, customer satisfaction, brand, and talent. And another key driver is the adoption of open source capabilities. Top performers on developer velocity are seeing 3 times more impact from the adoption of open source than the rest of the industry. Organizations who are best in class on open source capabilities score 30% higher on innovation and 20% higher on developer satisfaction. What enables all of these key innovation drivers is an organization's ability to empower developers with the right tools and platforms. And top performers who are empowering developers score 65% higher on innovation and drive 47% higher developer satisfaction and retention rates. However, innovation at scale requires embedding security into your developer workflow. You need to pair developer velocity with security best practices. Developers and organizations need to feel confident and secure to move at speed. Let's look at why this is so important and costly when facing today's threats. One emerging threat vector is the software supply chain, where 45% of organizations will experience attacks by 2025. Hackers are increasingly shifting left to target developers where they work. And this is even more alarming when you consider that security teams don't often collaborate with the development teams to pinpoint vulnerabilities early in the process. This comes with big cost. It can cost 60 times more to fix a security defect in production than in development. Fast remediation tactics are more important now than ever before. It can take only 3 days for a vulnerability to be exploited. These stressors on the business can hamper innovation and keep developers from what they do best, creating and building the future. Embedding security into the developer workflow aids developers in pinpointing these security vulnerabilities faster, provides more secure developer tooling, and creates the connection for more collaboration between security and development teams. For fast and secure innovation, an organization will need to adopt both best-in-class tools for code-to-cloud development and embed security into the developer workflow. With GitHub and Azure, we're building a tool set that helps you bridge across DevOps and SecOps teams and secure your development environments. Our solution to safeguard DevOps relies on two main components: providing developers with tooling to power innovation, and making sure that we are securing the developer workflow as code is being created. Security starts as soon as developers clone their code, and our solution starts with our development tools. Visual Studio Code and Visual Studio provide flexible and powerful developer tools for any developer, for any language, for any stack. GitHub Codespaces and Microsoft DevBox provide an entire development lifecycle tool, all in the cloud. This makes it super easy to onboard new developers to your team and to work with third parties. These solutions also have a lot of built-in intellectual property protection because code is no longer being dispersed into multiple locations. Additional components like GitHub Actions and Azure Pipelines help teams collaborate, develop, automate, and deploy the code that they want wherever they want. And we have security guidance and continuous security feedback within the developer workflow with GitHub Advanced Security, which includes code scanning, secret scanning, and dependency review. For identity management services, you can use Azure AD to instill zero trust security throughout your organization. And all of these capabilities work together when deployed in Azure, making this a complete solution for secure development. Now we'd like to share some demos and take a closer look at the building blocks of this tool set. We'll start with the tools for code to cloud development and then go deeper into securing developer workflows. There are many decisions to make on the path to build, deploy, and secure your application. The journey almost always starts with code, which can be in GitHub, on your machine, another remote location. And then you need to decide, what services will it run on? How will the application be monitored? What about debugging and secrets, roles, and permissions? How do I set up the deployment pipeline? And it can be hard to discover the best practices that relate to the type of application you are building. And one of the biggest pain points for developers starting a new project can be setting up their local development environment and CI/CD pipeline. This can often take up an entire day. We're working on how we can make this path simpler and faster. Here we're showing the idea of AZD, a simplified and straightforward way to get started on Azure with your code or a template in a language of choice. This is a way to get up and running with code, infrastructure, and deployment with simple, easy commands. In this example, we're showing a Node.js and Mongo database template hosted on GitHub. By using the up command, we provision the application infrastructure, configure the connections to the related services in a secure way, and deploy the application. The templates are idiomatic to the selected language and extend beyond Hello World to include monitoring, multiple languages, and to target hosts such as App Service, Azure Container Apps, and Kubernetes. Also included are additional commands such as pipeline to quickly generate a GitHub Actions deployment pipeline. I'd like to introduce Shane Boyer, who's going to show us these tools in action.
Hello, my name is Shane Boyer. I'm a Principal Program Manager on the Azure Developer Experience team, and I'm excited to show you what we've been working on to simplify and speed up developing apps on Azure. So you want to build an application on Azure, something with a front end that uses an API, displays data, but also secures the connection strings and has logging and monitoring too. Here's a to-do application for the Contoso team with a front end written in React and an API layer in Python using FastAPI. Each hosted on App Service, data storage is using Cosmos DB and the Mongo API, Azure Monitor for monitoring and logging, and Azure Key Vault for securing secrets. Using the AZD up command, I can start from an existing application template using React and Python, which then provisions and deploys this application in one command. Using the -- template option allows me to specify a template repo I have created or one that is available on GitHub from the AZD tool. AZD is a single exe installed on my machine using winget, apt, or homebrew, whichever is appropriate for your OS, and installs in a few minutes. I have the option of navigating to my template repo and using Codespaces as well, where all the prerequisites are ready to go. This means no installation of things like Python, the GitHub CLI, or other related tools, or worrying about incorrect versions or configurations that can take away hours from a developer's task. Here I'm ready to go immediately. Okay, Here we are back in VS Code, and in the integrated terminal, I'll run the up command with my template specified. I'm prompted for an environment name, subscription to use, region or location, and provisioning and deployment starts. I can navigate to the Azure portal and see all of the resources provisioned for my application. And then back in the terminal, the public URL is displayed once the provisioning is complete. Let's take a closer look at the structure of a code template. Each sample app comes with a README describing the application, services used, and everything you need from getting started to monitoring. The infra folder contains the infrastructure files describing the Azure resources needed for provisioning, all via Bicep. Each of the templates follow a common pattern of main, resources, and parameter files for consistency and repeatability for our customers. The source folder contains all of the application code idiomatic to the language of the template. JavaScript looks like JavaScript to a JavaScript dev, and Python feels familiar to Python devs. And of course, we love .NET, and Java's coming soon. GitHub Action workflows out of the box so you can set up the pipeline for this project. And finally, Azure.YAML, which ties the application code to the infrastructure code with some intelligent defaults for naming, environment variables, but no magic, all configurable and extendable. Let's look at the running application and see that our connection to the API and database are set up and working properly. The connection strings for the database are managed in Key Vault via secrets, and the other needed settings are securely set in app settings in each of the applications. We are taking a CLI-first approach to AZD. For developers who love command line tools, this will operate and feel familiar in WSL, Node, Python, Linux, etc. However, the same approach allows us to build VS Code and Visual Studio tooling, as seen here in the VS Code extension. Next, I'll use the pipeline command to create and connect my repo to Azure, as well as establish a GitHub Actions workflow for any future modifications to my infrastructure or my app code. I am prompted for creating or connecting a repo. Then the credentials and secrets are set up correctly to connect it to Azure, and then the initial commit and workflow is kicked off. Now that the pipeline is established and the app is running, adding infrastructure parts and extending the app using Redis is as easy as inserting the necessary Bicep code and variables and checking it all in to let GitHub Actions do the work. You can find out more about the AZD command line tool and application templates at aka.ms/AZD signup. We would love to hear from you about what kind of application templates would be most helpful to you, what services you want to use in the templates, and any other feedback you might have. Stay tuned for more news about when these tools move into public preview later this summer. Thanks again.
Hello, everyone. I am April Edwards, and I'm going to walk you through some advanced security features and where security fits into our development lifecycle. Security starts as soon as your developers clone their code. 85% of defects in our code are introduced in the development pre-commitment phase. This is mostly due down to human error. So we want to focus on security before we commit our code. So let's look at the development lifecycle. For pre-commit, we want to focus on how we write our code from our IDE of choice, whether that's VS Code or Visual Studio or GitHub Codespaces. Ensuring we're using the right tools to help us identify vulnerabilities and ensure that we write better code and more secure code. We need to make sure we're using processes such as peer reviews and encouraging better coding practices. When it comes to the commit stage, this is where we start taking on more extensive security methods to review the code, including static code analysis, using tools that scan our code as we check it into our source control. This is when we look at the credentials that we may have inadvertently introduced into the code base. This is called credential scanning, but may also be known as secret scanning or token scanning. We can also look for dependencies within our code. In the deploy section, we look at the overall health of that code base. We also look at the high-level security scanning and risks, cloud configuration checks, infrastructure as code checks, alongside security acceptance tests to make sure that everything is in line with the expectations and organizational security goals. Once code is being deployed, now it's a matter of operating and monitoring through continuous monitoring and additional threat intelligence. which not only helps us to see the current results, they also cover off the overall dependency vulnerabilities that we may be inheriting over time. We also do additional postmortems and make sure we can take away some lessons learned, and we continue iterating as we go through the DevOps cycle. So let's talk about GitHub Advanced Security. In order to make securing code easier for our developers, we've created native and automated capabilities to provide that continuous feedback using continuous security fixes through that lifecycle. We call this GitHub Advanced Security, which is a developer-first, community-driven approach to overall security. This consists of three main capabilities. The first one is dependency scanning. We continuously provide scanning to give you an idea of the risk levels of the dependencies that you're using. We also provide automated fixes to vulnerable dependencies that you may have in your code base. This is a continuous process. It nudges your developers in the right direction in a very friendly and non-obtrusive way. The second capability is code scanning. The secret sauce to code scanning is that all the scanning takes place as your code is being generated, without any additional steps to ask your code scanning to run at a separate location. All scanning takes place and results are published in that very familiar GitHub user experience. It's very easy for developers to fix early in that lifecycle. The third secret is secret scanning. This scans our code for hard-coded credentials or tokens. Next up, we have GitHub Advanced Security Production. We're introducing GitHub Advanced Security Push Protection that scans for secrets or tokens before they even get pushed to your code base. We check for high confidence secrets as the developer pushes their code and blocks the push if a secret is identified. We want to start secure and we want to stay secure. Currently, when you secure your workloads, there are a few challenges to manage. We have difficult to manage life cycles. We need to figure out how to get visibility into the activity of our workload identities, and does that enable periodic cleanup? Who owns the identity of these workloads, and how is this information kept up to date across changes in the organization? When was this workload identity last used, and when did we last issue a token? When does that token expire? We have higher potential for secrets or credentials to leak. What access do workload identities have, and how do you periodically review and remove unnecessary access? Access reviews where users are required to review their workload identities and remove unnecessary access privileges. Reporting on overprivileged access or underutilized access privileges. How do you ensure that these workload identities are not breached? Conditional access to ensure that access is originating from those expected resources. To add even more ways to secure your organizations, we're excited to announce the general availability of GitHub OIDC. With Azure AD Workload Identity Federation, it minimizes the need for storing and accessing those secrets. The new capabilities alleviate the need for managing Azure Service Principal secrets and other long-lived cloud credentials in the GitHub Secret Store. With this integration, you can manage all cloud resources securely in Azure. These capabilities also minimize the chance of service downtime due to expired credentials in GitHub. Customers can integrate with many developer platforms like GitHub Actions to swiftly and securely build our apps. How does Workload Identity Federation work? First, we need to set up that trust on your Azure Active Directory application, and we need to request that token. Then we need to configure the GitHub workflow to allow actions to get the token. The GitHub workflow sends a request to Azure AD. Azure AD then validates the trust on the application and fetches the keys to validate the token. Azure AD accesses the token and it is issued. And then the deploy action uses the Azure AD access token to deploy to resources in Azure. We're going to go ahead and reconfigure an existing Azure credentials secret that you may already have an existing workflow file. The first thing we need to do is go into the Azure portal. From the Azure portal, we need to create an app registration, unless we already have one. I've already pre-created one, so we're going to go ahead and go into that and go into the secrets and certificates. We're going to create a federated credential, and we want to go ahead and create a federated credential scenario. We have the option of GitHub Actions deploying Azure resources, Kubernetes accessing Azure resources, or other issuers, but we want to go with GitHub Actions. The first thing we need to do is edit the issuer. We need to go ahead and input our organization. I'm going to go ahead and import mine. Then we need to declare the repository in which our code is sitting in. We also need to configure the entity type. We have an option here to configure an environment, a branch, a pull request, or tag. In this instance, we're going to configure this against a branch, and I want to go ahead and configure this against my main branch. I also need to give my credential details a name. That has successfully created our new federated identity, and we've added that credential. Now we need to go back and configure our workflow with that new credential. To do this, I'm going to go into my code base in GitHub. Traditionally, I would go ahead and clone my code locally, but actually I want to spin up a GitHub code space. Why? Because it's a secure environment. We're going to go ahead and create a GitHub code space from scratch. I can choose which branch I want to create my code space from. I could have a lot of branches in my source code, but for now we're going to go from the main branch. I'm going to use the default dev container configuration. We can also import a code space configuration. We can also deploy our code space into different regions. I'm going to do mine from US West, and I can also change the machine type. So we're going to go ahead and create our GitHub code space. As this GitHub code space is creating, I also have the option to open this up in Visual Studio Code locally. My GitHub code space has successfully configured, and I can see all my extensions added in, including live share, etc. And I have full access to my source code. I'm going to go into my working GitHub Actions workflow file, and we're going to go ahead and edit that former entry for Azure login credentials. First thing I need to do is I need to add specific permissions into my workflow file. I need to add in an ID token with write access and a contents token for read access. I'm now going to go down to line 49, and I'm going to change my login. Where I traditionally would log in to the Azure CLI with that Azure credentials, I'm going to go ahead and change that. And now I'm adding in the different secrets. We have successfully replaced our former Azure CLI login using our Azure credentials that was using an Azure AD service principal in our GitHub secrets. And because these expire, that adds a huge risk to our organization. So now we've replaced it with the OIDC login to Azure. We replace it with a client ID, a tenant ID, and a subscription ID. I'm going to go back into our GitHub repository. Let's look at the other GitHub advanced security features. I'm going to go into our settings, go into our code security and analysis. We can see that we have dependency graph, dependabot, code scanning, and secret scanning. But I want to go ahead and enable push protection. It's as simple as clicking on the button. Now that we've enabled GitHub push protection, I want to go ahead and push a secret and see what happens. I'm going to open up my repository here, and I've planted a fake credential in my code base. I'm going to go ahead and do a git push. And we can see that my secret has been denied. GitHub Advanced Security Push Protection has picked up that this push has failed because it detected that secret and that credential in my code. This will prevent my developers from pushing bad code. I'm going to go back to my GitHub repository and let's look at some of the other GitHub Advanced Security features. From here, we can set up our security policy, we can set up security advisories and how we handle them. This is also where we'll see our dependabot alerts. Our dependabot alerts will automatically get tagged depending on if they're high, critical, maybe medium or low. I'm going to go into this dependabot alert and we can see that there's a dependency issue in our code base. I can see the affected version, where it should go, and how to remediate it, and it creates a GitHub issue for me. I can go to our code scanning alerts and see that it's picked up some clear text logging in my repository. It's tagged it as a high sensitivity, and this is done through the code QL workflow. I'm going to go into the workflow file and show you how this works. In this code QL workflow, it analyzes my code. It automatically sees that I'm running C# and JavaScript. This also supports things like Go, Java, Python, and even Ruby. So it'll pick up the language that we're using in our code base and scan that code for those issues. Let's go back into our code base and look at that secret scanning alert. We can see here that we've exposed an Azure Storage account access key. I can click on it, look at remediation, and it logs it as an issue, and it also gives me remediation steps for my organization. So now that we've changed our OIDC connector and looked at GitHub Advanced Security features with push protection, let's go back to Mandy.
Thanks, April. With these new Azure and GitHub capabilities, you get best-in-class tools and secure developer workflows so you can build in the cloud quickly and securely. If you want to learn more about secure DevOps, we have a new ebook, Securing Enterprise DevOps Environments. Within it, we walk you through the ideal secure and regulatory-ready setup of enterprise DevOps tools and practices. We focus on 3 specific areas: securing the developer environment, securing the DevOps platform environments, and securing the application environments. Thanks for joining us, and we would love to hear from you about how we can help you build fast and secure DevOps practices. Please sign up for the Azure Developer CLI private preview by registering at the link below, and you can check out how to set up GitHub OIDC with Azure AD Workload Identity Federation within the documentation. And don't forget to read up more on secure DevOps with our new ebook and blog. Thanks again, and enjoy the rest of your session.